All right. Hello, everyone. Thank you for joining. If you're seeing this means that you are watching the live stream. So please ask any questions that you might have today in the chat as I go through our topic. I'm going to be walking through some quick slides, and then I'm going to show you all a demo. And at the end of the demo, I'm going to circle back to the chat and answer all of your questions. So I'm really excited to have you all here. I'm ready to jump into it. If you all are having any trouble with the audio, try refreshing your page. We have noticed that sometimes when we go live, the audio isn't cut off right away. So if you're having any issues, just give that a little bit of a shot. And yeah, thank you for being here, and hope that you all get to learn something new today. So, hi, I'm Franz Pear with Cyber Skyline, and today we're going to be learning how to look up PGP keys using a key server. So PGP stands for pretty good privacy, and it's used to facilitate asymmetric key encryption. And I think it'll be useful then to get a quick overview of how asymmetric key encryption works. So let's create this hypothetical scenario here where let's just say Bob is a reporter, and Alice has some juicy tip. She wants to send this information to Bob, and she wants to make sure that no one else can know about it, right? She trusts Bob to report on it and keep her confidential, and she wants to make sure that no one else knows what this message is. And so the way that asymmetric key encryption works is that Alice would need to take Bob's public key. She'll get his public key, and then with her message and Bob's public key, she will run that through the encryption function, and then she gets the encrypted message. And then she can send that message over to Bob, and Bob has the private key that can decrypt the message, and only Bob's private key should be able to decrypt the message that was encrypted using his public key. So he'll take his private key and then stick it in there, and then he's got his decrypted message. So that is how asymmetric key encryption works. Now, going back to this hypothetical scenario, right? It poses a question: how does Alice get Bob's public key? Because in the previous slide here, she needs his public key in order to send him a message that only he can decrypt. So how does she get that? We're assuming that Alice and Bob, they've never met each other before. And so she needs to be able to get his public key. Now, this would mean that Bob, ahead of time, would need to publish his public key somewhere, right? That would be the only way that Alice can get it. Assuming they don't know each other personally, Bob needs to publicize it over the internet. And there are a couple of ways that he can go about doing that. And ideally, he attempts to publish it in as many places and as ways as possible, because that's going to help increase the amount of trust that other people will have that the key that he's been publishing is actually his. And I'm going to go into a little bit more detail that with these two primary examples of methods that I'm going to show you. So let's start first with key servers. So key servers, they do exactly what the name implies. They are servers that store keys. They facilitate the uploading of these public keys along with a corresponding identifier. So what this means is that Bob can upload his public key to the key server along with his name and his email address, for example. Now, there is a limitation here that most key servers don't by themselves verify the identity of the person uploading the public key. So that means it's possible for someone who isn't Bob to go and upload their public key pretending to be Bob. They could have Bob's name and Bob's email address. They upload that, but that's not the real Bob. That's fake. And so we need a way to address this problem. If any random person can go and upload keys, how do we know that this is the real Bob? So with key servers and with PGP as a whole, the idea is to create what we call a web of trust. And the idea is that you basically have people vouching for each other to verify that, yes, this is the real person. And the way that this is done via key servers is that you will do something called signing someone else's key. So you'll take your public key, and then you will basically publish this message that says, this is who I am, this is my public key, and I am confirming that this public key is who they say they are. That's kind of what it's doing, like practically speaking. In terms of the code and the specifics there's a lot more technical stuff there. But in essence, the idea is that you're vouching for someone else. So going back to our example here, let's just say that Alice is, so Alice doesn't know Bob, but let's just say Alice is friends with Charlie. And she, because she's friends with Charlie, she can talk to Charlie and she can verify that when she looks up Charlie's PGP key on the key server, which particular one is actually his. And Charlie also happens to be friends with Bob. And since Bob has uploaded his PGP to the key server, and because Bob and Charlie are friends, what they've done is they've signed each other's PGP keys. So they vouch for each other. And so now when Alice is searching for Bob's PGP key using, let's just say, his email address, let's just say she gets multiple records, right? There are a lot of people trying to pretend to be Bob. They want to get all these juicy secrets. She can feel more confident that the one PGP key that is associated with Bob's email address, that one which was signed by Charlie, the one that Charlie's vouching for, that's more likely to be the real one. Now, this is not a perfect solution because maybe Charlie made a mistake and he signed the wrong key, or maybe he was tricked and he got social engineered and who he thought was Bob isn't actually Bob. And so you probably don't want to just rely on one person doing the vouching in this system. And so the more you can build out this web of trust, the more people who are vouching for the public key, the bigger the overlap there is between who Alice trusts and who is vouching for Bob. The more that overlap, the more that Alice can be certain that she has the right key for Bob. But she can never be sure. It's kind of just the level of comfort, the level of trust. So that is how key servers work in a nutshell. It sounds kind of complicated, and it's not particularly practical, because when you go and you want to send a message to someone, you're probably not going to want to jump through all these hoops of looking them up in a database and then going through the list of all the people that vouch for them and then seeing if you know any of those people. And then if you don't know any of these people, then what do you do? So it's not the most practical thing for most people on a day-to-day basis. However, they are still very heavily used to identify people, especially for open source projects. And so for like a high profile open source project where you want to make sure that the people who are pushing out code that's being deployed on like millions of devices, those people are who they say they are, this is a very critical resource for people in that community to verify people's identities. So let's go into the next item here for internet profiles. And this is very broad. So internet profiles can mean social media pages. So, your Facebook, your LinkedIn, your GitHub. It could mean your personal blog, for example, kind of anywhere where you have an online identity. That's what I'm referring to as an internet profile. And so let's say Bob, he posts his PGP key on his social media profiles, his GitHub, maybe his personal website. And so if Alice is able to go and she searches for Bob and she finds Bob's website and she finds his GitHub profile, and both of them are saying, hey, this is Bob's PGP key, they both match, then she might feel confident that this is in fact Bob's PGP key. And it's a lot more convenient than going through a database and looking through the list of people that are vouching for this person. And if you have any overlap in people that you trust, instead of doing all of that, you just go to their profile and you hope that the GitHub profile, you got the right GitHub profile. You didn't get the wrong GitHub profile. And this is why the second method is also not entirely foolproof, because again, someone could create a fake website pretending to be Bob, and they could also create a fake GitHub profile pretending to be Bob, and they could trick Alice, and Alice could think that she has Bob, and it turns out that that isn't actually Bob. And so this is why it's so important that if you are kind of going to be using PGP, especially if you want people to use your public key to send you messages, that you are using as many ways as possible to build that web of trust. You post it on key servers, you get people to sign your key, you sign their keys, you post it on your internet profiles, because the more and more ways that you can kind of use different touch points to kind of verify that you are who you say you are, the more that people can have trust in your profile there. So that is a very, very kind of like rundown overview of how this works. And actually being able to identify people's identities online is really, really challenging. And this is kind of the common ways that people have gone about approaching this challenge. So internet profiles, I don't think you all really need a demo to pull up someone's GitHub profile and find their name and find their key if they posted it on their profile. But what I'm going to show you is key servers, because you probably are familiar with using social media. You're probably not familiar with using key servers. And so using a key server, it's the steps are very straightforward. It's just the results that you get are going to take a little bit of time to understand how to interpret what information you're looking at. And so just 3 steps here, right? The first step is you want to use a well-known key server. I've provided a couple of examples here. There's one that Ubuntu runs. There's also the one from Open PGP and the one from MIT. These are some pretty common ones. You can kind of use them. The reason why you want to use a well-known one is that there's there's a bigger web, more people vouching for each other on those key servers. And also, you probably don't want to just trust any old random key server. You want to make sure that the people who are administering this key server have some integrity as well, so that the likelihood that you're getting tricked is lower. In theory, whoever's running these key servers, they can fake some of these, like they could basically add in fake data and trick people that way. So it's important to use a reputable key server. Once you have the key server, though, all you have to do is just search for the name, email address, or signature. Different key servers will have different ways of doing the searching, but usually you're searching for an email address or someone's PGP, like their public key signature, and then you just review the results. So pretty straightforward. And I think we're probably ready to go into a demo here. So let's go and actually try to look up some of these PGP keys. All right, so I have pulled up one of our practice challenges here. And in this scenario, we are needing to do a PGP lookup, and we have 3 questions here. We need to find the key fingerprint for this email address. And the key fingerprint is effectively the kind of like the signature. It's like the easier way to refer to the PGP key, because the PGP key is a very, very long sequence of characters, and the fingerprint is going to be a shortened version of that, which is easier to use. The second question is asking us to basically look up a key fingerprint and figure out whose email address is associated with that fingerprint, and then also figure out when does that expire. So those are our 3 questions here. And what I have done in advance is I've already opened up a tab for the Ubuntu Open PGP key server. And so going to that first question, we're going to look up this email address and see what we can find. So this is actually the screenshot that you saw in the slides earlier. And I'll zoom in a little bit, hopefully make this a little easier to read here. And you can see that we actually get 2 results, 2 hits. And we have the cPanel master key, which uses this email address. And we have the cPanel security team. They use the same email address. So it's entirely possible that you basically have these 2 keys that might be used for different purposes. I don't know exactly like what the cPanel master key is used for versus the security team key, but they're both associated with this email address. And the way to read this is that you can see here, this says pub. So this is the public key. And then we have, this is an RSA 4096 bit. So 4096 bit RSA key. And this is the key ID that follows, right? So bits/key ID. So this is the key ID, which is the same thing as the key fingerprint. It's the same thing. So we can just copy and paste that, and we've got that correct. Now, because there are multiple results, and this question is asking for this email address, and there are 2 valid ones. And you can see here that there are multiple entities who've signed this, and the question is not asking for validation. Either one of these would be valid. So I could have gone and I could have pasted this other signature and would have gotten that one correct. The next question is asking what email address is associated with this key fingerprint. So going back here, let's go and run another search, and I'm going to run that signature in here, and there we go, one result, and we're looking for the email address. And so the email address is this right here. So copy that and paste that in here. And now we're being asked, on what date does this key expire? And so there is a field here for the key expiration. And you need to make sure that you don't get confused when you read these, because at least in these results, the columns are not super obvious and when you're viewing it, because you might just take this, assume this is correct, and submit it. But up here, there's the creation time, the CR time, the expire time. And so this is actually the creation time, not the expiration time. So looking deeper in here, you can actually see this is the creation time, again, for the key here. And actually the expiration time is this one, the one that is expiring in 2050. So this is going to be 2050, December 26th. And there we go. So that is how you can use a PGP key server to look up PGP keys, either by the email address or using the key fingerprint. And the one thing I also want to make sure that you all kind of take away is be very careful when you're looking at the results. Make sure that you're looking at the right column, because it is very easy to get confused if you're not paying close attention. So I hope you all found that helpful. All right, so now I'm going to go over to the audience questions. So for those of you who have been asking some questions, I'm going to go through it. If you have any questions, please ask them now, and I will try to get through them all. So very first question here. From Brian, maybe a QR code with a PGP code inside of it, then all your selfies will advertise it. Yeah, I mean, you can share it multiple different ways. I don't know which selfies you're referring to. I'm not sure if you mean like Snapchat or whatnot, but yeah, you can share your PGP key in many different ways. The more the better. Another question is, are DNS record types used for PGP keys? I am not familiar with PGP record types being used for PGP. It depends on what you mean by the question. If you mean in terms of the verification, like if you are using a DNS record to verify your PGP key, I believe that there are ways to do that. Yeah, I assume you mean the verification. Yeah, I would say yes. Either directly, you might have like a TXT DNS record for your PGP key. I'm not sure if there is one specific to PGP. Maybe someone in the audience can comment on that. But I also know that this could be a mechanism for a key server, depending on who's running the key server. They might require you to insert a DNS record with your PGP key to verify that you do indeed that is indeed you, so that random people can't just upload the PGP keys. So I know that is a thing, and it will depend on who's running the key server. They don't all follow the exact same standards. Carnegie is asking, are there any blockchain solutions to implement PGP key advertisement? Good question. I have no idea. This does sound like something that, in theory, blockchain should be addressing, but I am not familiar with that. Maybe someone in chat can speak to that. James is asking, is there an algorithm or a score? Does it check the trustworthiness of people vouching? So the underlying protocol, the underlying process of PGP and the open, like, I forget what was this open PGP key server, the hockey puck open PGP key server, they do not implement an algorithm or a score to check the trustworthiness. I'm sure that likely there are people or companies who've created their own sort of score or algorithm to do that. But there is not something built into the protocol. That is someone kind of creating their own thing on top of it. So that's not necessarily universally recognized. James is asking, do PGP servers have protections against bots? It will depend on the implementation of the key server. I mean, anyone can create a key server. You can use this open PGP key server, which I'm pretty sure this is an open source project that you can go and download. And I don't know if they by default have those protections. I can guarantee you that the versions of the key servers that are being hosted by, you know, the MITs, the Ubuntus of the world, they must have protections. Otherwise, their results would be completely useless. So yeah, there are some protections, but it's not a perfect solution. It's a band-aid solution. You still need to have other mechanisms for validating trust. Isaac is asking, what types of algorithms does PGP support? I know at a minimum they support RSA, but this is probably just a good Google search. So PGP, and I'm just going to go to the PGP Wikipedia page. If I pull it up here, I'm sure it will give us some sort of if I search for RSA, okay, it uses RSA or DSA. Yeah, I'm not as familiar with DSA, but there are other algorithms. Will require some additional investigation to see if they're more than just that. Brian is asking, do you think PGP will ever get more adoption or remain more niche? So I think that the underlying technology will get more adoption, but using the protocols and using key servers manually is not really going to get more adoption. You might have technologies built on top of those which will do that adoption. So maybe, for example, I know some email clients have built-in support for PGP, and it does everything that I kind of described in terms of like verifying people's identities and signing other people's certificates. Those kind of happen in the background. Maybe you just click a button and verify, like, oh yes, I know this person, I'm going to vouch for them, and that'll do the signature and I'll upload it to the key server and everything without you needing to interact with the protocol by hand, using the key servers by hand. You just press a button and it does it behind the scenes. So yeah, likely this technology will get more adoption, but in terms of how do people interact with it, it's probably going to be just simplified for them, and a lot of this will happen behind the scenes. James is asking, what prevents someone from generating a lot of keys that sign each other? So nothing really. There might be some of that anti-bot protection like we were talking about with the actual key servers. But yes, in theory, you could write a script that just keeps generating PGP keys and you'll have each other all sign each other. Now, the problem is you have to build that web of trust somehow, right? So unless someone is putting those keys on their social media profiles, or unless like there are people who are trusted by others who are signing those keys, then it's meaningless. So you can see a key that was signed by like 1,000, 1 million different other people, but if you don't know who those people are, then you wouldn't put any weight, in theory, you wouldn't put any weight in the fact that they did sign each other's keys. So that is something where you would need to get like, it's basically like you got to find the PGP influencer. Like, who are the people who have those profiles, who are trusted in the community, who would sign your key? And as an individual not trying to abuse the system, what you would do is like you would get your friends to sign it. Maybe you have like a professor that like they will sign it, and that professor knows other professors at other schools, and they know like actual developers in the community, and then they know, and then this web of trust starts getting developed that way. You actually need like real people to start signing them, because having a bunch of signature like keys that are just signed by each other inherently has no value. You're basically just building your own discrete web of trust, which is completely separated from the rest of the world. All right. Jay's asking, what tools and software are needed for PGP key lookup and verification? I mean, there's a lot of different options. What I just showed you today, you don't actually need to download anything. You can just go and use the open PGP key server from like Ubuntu or MIT or any of those different sources that I have listed. I'm not super familiar with a lot of the actual like Linux command line tools because I'm actually personally a lot more used to using PGP, like I described, with a lot of those automated tools behind the scenes. So yeah, it's likely possible that there's a lot of PGP usage that I'm involved in that I don't even know that it's using PGP like underneath it. All right. Well, I think we're gonna call it there. Hopefully, you all found that useful and learned something new. If you have other suggestions for topics that we should cover in the future, please let us know in the chat. Yeah, hope you all learn something new, and good luck out there solving your challenges. Take care.